Hey calculus students, I wanted to finish the example we were working on in class where we used the first derivative test to find the relative minima and maxima of this particular function. In class we had taken the derivative and determined that it was 4x over 3 times the cube root of x squared minus 4. We set that equal to 0 to obtain the critical number x equals 0. And we also defined that the function was undefined if x was plus or minus 2. So we found then that our critical numbers altogether were -2, 0, and +2. So what we were in the process of doing when the bell rang was filling out our sign line for those three values. So here's -2, 0, and +2. We're interested in finding the sign of our derivative for each of these intervals, from -infinity to -2, from -2 to 0, from 0 to 2, and then from 2 to infinity, because what our derivative is doing, or the sign of our derivative on each of those intervals, is going to tell us whether or not these three values are mins and maxes. The first thing we want to actually take a look at is that our function is actually, our function itself, not our derivative, but the function itself is continuous at all three of these points. So we don't have to worry about anything really funky like we will with some rational functions that we might look at further examples of. So we just need to figure out what is the sign of the derivative on each of these intervals so that we can see what the sign of the function is. So I'm going to rewrite the function over here, the derivative, because I'm going to write all over it. Or I guess just 0.2 and a lot, x squared minus 4, and then I'd have a 3 out front. Okay, so there is our derivative. So let's look at this interval here when x is less than -2. If x is less than -2, then x squared is greater than 4. So we get a number greater than 4 minus 4, which means for -2, our numerator is negative. If we plug in a number here for x, it's less than -2. Our denominator is positive. A negative over a positive is a negative. Then let's look at between -2 and 0. So on the interval from -2 to 0, it looks like our function, if I plug in something in the numerator from that interval, our derivative is again going to be negative in the numerator. But if I look at the denominator, this number here, x squared, if x is between -2 and 0, is going to be less than 4. So this number will be negative in my cube root. Cube root of a negative is a negative, so I have a negative in the numerator, a negative in the denominator, which means altogether that gives me a positive for that interval. For the interval from 0 to 2, if I plug in a number between 0 and 2, I get a positive in the numerator. And in the denominator, again, I'm going to get something that's less than 4 here. If my x is between 0 and 2, my x squared is less than 4. And so I get something that's negative here. A positive over a negative is, again, negative. And then from 2 to infinity, my numerator is positive. And then if I plug in a number from 2 to infinity, this number is going to be greater than 4. So this quantity here is going to be positive. And so cube root of a positive is positive. So I've got positive in the numerator, positive in the denominator, which altogether gives me positive. So here's my sign line. It looks like I can identify then, remember, the relative min occurs when my function goes from decreasing to increasing. A relative max occurs when my function goes from increasing to decreasing. So it looks like -2 then is a min, 0 looks to be a max, and +2 looks like another min. So the last thing I need to do is sum up the results for my first derivative test. So I'm going to write that f has a, and I'm going to say it has a relative min at x equals -2, since the function is continuous. The derivative is undefined, and the function, or excuse me, that should be the derivative, goes from negative to positive there. And then let's see, at 0, f has a relative max at x equals 0, since the function is continuous. The derivative is 0, and the derivative goes from positive to negative there. And then lastly, I want to say that f has a relative min at x equals 2, since the function is continuous. The derivative is undefined, and the derivative goes from negative to positive there. Okay, that completes our application of the first derivative test for this particular function. If you were to graph this function to confirm your result, which you always should if you have access to a graphing calculator, you would see that our function in this case looks something like that. It's a really weird function. It has these two cusps. That's why our derivative was undefined. The derivative is actually discontinuous there. And then we see we have this relative maximum here. So this relative min occurs at -2. This relative min occurs at +2. And this relative max occurs at x equals 0. But we didn't have to graph it. We used analysis to discover that. For homework, as a reminder, please do page 186, numbers 17 through 49, every other odd. All right, and also please remember to start working on your Chapter 2 review in the Chapter 2 study guide, which I emailed to you on Saturday. Okay, thanks for watching and enjoy.